Right, okay, let's have a look at question 12 on the quickfire questions. The one with the helicopter. I'm going to draw a diagram, free body diagram. You just draw a square or a circle for free body diagrams. You should remember that from GCSE. The first force that is shown is the thrust. And that is at an angle of 10 degrees from the vertical. And then the second force shown is the weight, which is 19,000 newtons. Okay. And the question says the vertical component of the helicopter's thrust is equal to its weight. Calculate the helicopter's thrust. So it's the thrust here that we're going to try and find. Okay, I'll probably just call it T from now on. Now the way to do this is, it's all the question's already suggesting components, but the way to do this is to resolve the thrust into two perpendicular components. So that is the vertical component, T vertical, and this is the horizontal component. Okay, and we are also told that the vertical component, this component, is equal to the weight, and that must mean there's no resultant force and the helicopter isn't accelerating upwards or downwards. It's either stationary or potentially is at constant velocity. So we know, let's write that down as well. We know that T vertical is equal to 19,000 newtons. Okay, that's important. Right, so let's look at the components here and put them into a right angle triangle. So if I draw the thrust T, that's going to be the hypotenuse, isn't it? And then if I put the horizontal component here, T horizontal, and the vertical component, I'm going to move over to there to make my right angle triangle. So that is T vertical. Okay, now ask yourself which of these, that's obviously the right angle, well, which of those two is your 10 degrees? Now if you've drawn it reasonably well, you should see that the smaller one is here. But if you haven't drawn it reasonably well, and it's good practice anyway, let's go back up here. This is the angle that we're looking for, isn't it? This one here, yeah. If that's 10, these are Z angles, so that one there is 10. Okay, so we're going to use SOHCAHTOA or one of those to work out what T is. Okay, so we know T vertical, and that is 19,000, yeah? And T is what we're looking for. So we've got the adjacent side, and we're looking for the hypotenuse. Which one of these three we're going to use? Correct. Cos of the angle equals adjacent over hypotenuse. So cos 10 equals the adjacent side. Let's just put this on here if you weren't sure. Adjacent, and that's opposite. Cos of 10 is the adjacent angle. Sorry, the adjacent side over the hypotenuse, which is T that we're trying to find. So now we've got an equation with only one unknown. We can calculate cos 10. But let's rearrange this. I'm going to take T over to the other side. If it's divide here, it becomes times. And I'm going to take cos 10 over to the other side. It's times here, so it becomes divide over there. All right. Work this out on your calculator, and Let's have a quick look, hang on. 19,000 divided by cos 10 equals, here we go, 19,293 newtons. Okay. Then when you come to number 13, actually, number 13 is moving on from this one. Now you need to calculate the horizontal acceleration. The horizontal acceleration. So if there is an acceleration, there must be a resultant force horizontally. What's the resultant force? Is this component, the horizontal component of the thrust. So if you can now work out what T horizontal is, then you can use that. So remember this symbol here for resultant force. The resultant force is T horizontal, and remember that from Newton's second law, yeah, force equals mass times acceleration. So we calculate this going back and using Sokotoa or something again, and then do we know the mass? Well, we know the weight, and we knew W equals mg, where G is 9.81. So don't worry too much about that one. Have a go at it, and you can see it in the answers.